Good evening, ladies and gentlemen. My name's Professor Brett Kirk, and I'm the Acting Deputy Vice-Chancellor of Curtin University, and I'll be your Master of Ceremonies tonight. I'm delighted to welcome you all to Curtin University on this evening and for the public lecture, Surveying and Reconstructing the HMAS Sydney and HSK Kormoran. I'd like to begin by recognising the traditional owners of this land and the Whadjuk Noongar people of Western Australia and pay my respects to their elders, past and present. Just a couple of housekeeping issues. Could everyone please make sure they turn their mobile phones off or to silent? And if there is an emergency, please follow the instructions of the corporate events staff. And if we're required to evacuate, we'll just collect in front of the car park in which most of you parked in the very unlikely event. The Sydney-Kormoran Project is a highly collaborative venture. I'd like to acknowledge Dr. James Dexter, Director, Creative and Regional Development, Western Australian Museum, Mr. Bob Trotter, OAM, and Mr. Ted Graham, AM, both of the Finding Sydney Foundation, and Mr. John Loffridge, Executive Vice President of Asia Pacific of DOF Subsea. All of these have been critical partners for this venture. Tonight is a very special occasion for Curtin University and another step in our long association with the HMAS Sydney and HSK Kormoran project. That history commenced with the sinking of the HMAS Sydney on the 19th of November 1941, 12 days after which the university's namesake, Sir John Curtin, finally announced to the public that the HMAS Sydney had been lost. Since that time, mystery has surrounded the sinking of the two ships, with many theories being proposed, debunked, and further contested. As a place of higher learning, Curtin University is now playing a role in contributing to the knowledge relating to the largest ever loss of Australian life in naval history, where 645 Australians lost their lives. And of course, not to forget the 80 German crew of the HSK Kormoran. The roles of universities are manifold. We provide teaching and learning opportunities for undergraduates, research for industry and government, and of course, community engagement where the university shares its knowledge with the broader community. The Sydney-Kormoran Project is an amazing project that enables us to engage in all of these activities. I would like to acknowledge three very important organisations who have helped make the 2015 Sydney-Kormoran Project possible. Firstly, the WA Museum, and particularly its CEO, Dr. Alec Coles, who could not be with us here tonight, and also the unstoppable Tim Eastwood. Dr. Coles and his team has been instrumental in sourcing funding and of course the permissions for the museum Curtin team to revisit the two ships. The partnership with the museum is a long and enduring one and will continue to provide benefit for the Western Australian community. Mr. James Dexter will tell us a little bit more about the museum's future plans in closing tonight's event. Secondly, DOF Subsea, who many of you may not know, is a Norwegian headquartered company that provides marine services for the oil and gas industry. As part of its contribution to the Australian community, DOF's exceedingly generous contributions enabled the locating of the two ships in 2008 and again provided their unique services to the 2015 project, an act of exceptional generosity. Thank you to John Loffridge, Executive Vice President, Asia Pacific, and your extraordinary team. I would also like to acknowledge the members of the Finding Sydney Foundation, whose tenacity and courage led to the discovery of the resting place of the two ships, and whose guidance to the museum and Curtin ensured that the needs of the family members of the lost crews was always front of mind. Thank you for that important contribution. Finally, tonight is not only an example of collaboration between industry, museums and universities, it is also an excellent example of collaboration within Curtin itself. Tonight you will hear from two Curtin researchers who have been instrumental to the Sydney-Kormoran project in Dr. Andrew Hutchinson and Dr. Andrew Woods. But you'll also hear how broadly this project has been supported at Curtin and how it has become more than a digital curation project. It is a project that will see marine scientists, cultural historians, visualisation experts, geochemists and corrosion scientists generating new knowledge for years to come, and that's very appropriate in this research week for Curtin University, as so many of our great projects are multidisciplinary and multi-partner. So it's on that note that I now invite Dr. Andrew Hutchinson from the School of Design and Art in the Faculty of Humanities to the lectern.
Thank you, Brett. So this story, of course, starts with an historic tragedy. In 1941, these two ship's captains, Theodore Dietmers on the left, in charge of the Kormoran, and Joseph Burnett on the right, in charge of Sydney, met unexpectedly in the Indian Ocean, and the result was the loss of the Sydney, here on the right, with all hands. The Kormoran was also sunk, but with a much lower loss of life, and there were hundreds of survivors who were recovered from the water. This was a very unexpected outcome because the ship on the left, the German ship, was a converted merchant ship. The ship on the right, the Sydney, was literally the pinnacle of the state-of-the-art of British naval military technology. So this unexpected outcome led to the great controversy that followed and went on and on for years. So this is the crew. So as I came into working on this project, doing the background research, I came to discover that naval personnel don't think of a ship so much as metal and wood and guns. They think of the ship as a collection of people, a community. So this is a photograph from Sydney's high point. The Sydney was already a popular culture figure in Australian society before it was lost. It had been famous in pre-war propaganda. It had become even more famous due to a famous victory in the Mediterranean. And this is the victory picture of the Sydney's 645 crew. Crews were very tight. There was some mobility of crews, but an enormous proportion of the men in this picture were on board when the Sydney was lost. So the Sydney came home from the Mediterranean and was given a hero's welcome, as one would expect, particularly in its namesake city and port. So this picture was the front page of the Sydney Morning Herald, and as it says here, 9 months later, William Bill, I'm sure he was called, was lost. So this is the Sydney in the background. This is Circular Quay. And as you can see, it's a beautiful, it's a heroic, it's a poignant, it's an iconic image of the sailors' welcome home. Now, of course, the reason I'm showing you this picture is because what really drives this project is a desire to retell a story, to recommunicate the importance of our background and our history, and that is beginning to fade. So when I was a kid, you met World War II veterans. Everyone knew them, everyone knew their stories. But that's no longer the case. We are living at an important moment in history when the veterans, those people who had the personal experience of living through the Second World War, are at the end of their lives. And so this whole event in history is about to slip from living memory. Now, so interestingly enough, Bill and Dawn, his children, they may well still be alive. So this is a very real story. So of course, millions of children lost a parent during the Second World War, but not too many Australian children have lost a parent and had to live with the controversy and the doubt about what really happened to their parent that Bill and Dawn will have. So this controversy went along well into the 1980s and through the 1990s, and finally the Finding Sydney Foundation got together enough money and resources and found both Kormoran and then Sydney in 2,500 metres of water. This was a huge achievement. They were found here off the West Australian coast. Carnarvon's in about here, Geraldton's about here. So this is about 200 kilometres off the coast, and the water here is extremely deep. so not easy to get to. So following that discovery in 2008, I became very interested in the idea that there would be the retelling of the story using the visual material gathered. And we imagined here at Curtin University, because we're very interested in new technology, and that's my interest in design, is how we can use new technologies to communicate stories, new and old. And digital technologies are a big deal and having a huge impact on museums. So this is an early visualization of how we thought this might go. There's a rich source of archival image of Sydney. What we would now call embedded journalists were on board the ship in peacetime and in wartime. And we imagined that there'd be a virtual environment where people could go and sit and move around the wreck of the Sydney and experience for themselves a battlefield visit. They could go and bear witness to what had really happened. Now, the 2008 image, and these images are from the 2008 archive, some of the images are incredibly tantalizing. They hint at a bizarre and unexpected beauty, the marine life that has gradually transformed these wrecks into an undersea landscape. And then there are these very poignant images. Two shoes lying together on the seafloor. And I don't need to say what, of course, that indicates. But a problem we had with the 2008 archive, and this is some video from then, is that while this material we're looking at now swept away the controversy and brought back the Sydney and the Kormoran from folklore and allowed a government report to prove what had happened to the Sydney and the Kormoran, which was basically that what the Germans said had happened, had indeed happened. This material is sketchy. It's low resolution. It's not suitable for presentation to a general audience. And indeed, that's why there hadn't been a bigger exhibition about the Sydney and the Kormoran before now. So we realized that if we were going to do what we wanted to do, we were going to have to go back. Now, this is an unimaginable dream, really, for a bunch of university academics or researchers to somehow get access to the incredible resources it would require to take high-resolution cameras back to the bottom of the sea. But it happened to us. So Andrew Woods and I, who's going to speak soon, were doing a presentation at lunchtime in the city to DOF Subsea's people, and at the end of the presentation, their regional manager stood up and said, "If you get your stuff together, we'll take you back." Now, I don't know how much money that represents, and I am scared to ask. And that's why this has been described as a gift to the nation. Alec Cole, CEO of WA Museum, has described this in that way, and I think that is a very appropriate way to describe it. So we suddenly found ourselves in a whole lot of trouble, which is we'd said, oh, we could do this, and now suddenly we had to do this. So we then started, now I should say this is 4 years ago. So pretty much from that moment till now, we were working extremely hard on proving we could do it. So this is my colleague Andrew Woods in this picture, demonstrating the enormous size of this ship. So this is the HMAS Anzac, a currently serving missile frigate, which was in dry dock, fortunately, in Henderson. So we wanted to practice our technique for photography on a real-sized warship, and I told Tim Eastwood, who's here at that, wouldn't it be cool if we had a real warship? And he rang me back about 3 days later and says, I have got you a real warship. So the Australian Navy said they were happy for us to come in and look at it, and then photograph it. And, excuse me, I'm jumping ahead here. So what we had was the perfect test model. So this is a real warship. It has these real shapes. It has the long, lean lines of what would now be called a cruiser. Beautiful at the front, ugly at the back, whereas the Sydney was actually beautiful at both ends. It was a very different design in the stern. But what was terrifying for us was to realize just how big a task we had undertaken. We weren't going to completely 3D scan a photograph in high resolution and do cinematography of just one warship. We were going to do 2 warships if we got the time. And indeed, it wasn't that simple either, because both ships are surrounded by an enormous debris field of things that have been destroyed or fallen off of them. So we had our work cut out for us. Now, I don't, unfortunately, have time to take you through every trial and tribulation of 4 years and everybody who helped us. And some of that will come out in the following talks. But suffice to say that it takes a very multidisciplinary team to do this many things all at once. The project gathered pace and speed. So I come from art and design, and I'm in the design side of things. So that's where we're used to mixing up aesthetics and doing creative problem solving using technology. So my area is always looking for new technology. But very quickly, we then started to involve other organizations inside Curtin University, and we ended up down here with a lot of scientists, because it's very rare to get a ride to these depths, even rarer to get the opportunity to examine shipwrecks, which have this extraordinary impact on the environment. Even rarer to find 2 together and to know exactly what day they sank on. So there was a whole lot of happening. And as you can see, DOF Subsea, of course, were an extraordinarily important foundation partner for us. Veterans groups were involved because, of course, there are very serious issues around the respectful approach to this kind of work. We are, after all, going to a very important place that is quite literally the last resting place. And you can see this long list of organizations who've somehow gotten involved. And I have got to say, we have been overwhelmed by the many smaller oil and gas services and operators who have given and given and given and given and given to this project. And it just would not have happened without their help. So more detail about what we've actually done will come straight after I finish speaking. But what we were trying to do, we've achieved that and more in many ways. Really, what I started out wanting to do was to tell the story to a much younger audience using digital media technologies that they think are natural, that we did not grow up with. But of course, people who are just a little bit younger think it's completely normal to be interactive online in social media. And this is having a huge impact in the way we communicate and tell stories. So the idea of doing this virtually seemed to make sense. We're also preserving these wrecks. As you'll see, these wrecks are literally decaying. The sea is gradually taking them back, and they won't be there forever. At the moment, these wrecks are recognizably the way they were on the surface. Very damaged, but you can see what they're doing. But also, people just can't go there, and maybe they shouldn't go there. So the opportunity for us to allow people to get there, to these remote places, is important. And all these other outcomes. So one of the most astonishing experiences I've had on this project was to meet and interview and talk with and laugh with some men who were on the original crew. They are in the big picture I showed you earlier. And they had been transferred off to other ships just beforehand. So this is Jim Lavender, and this is Jim in Fremantle Harbour in 1940 or 1941. And this is Jim in Busselton last year. And we met him and we interviewed him, and he told us a lot about the ship. He had done a lot of different jobs, and he was very concerned that the 4-inch gun he had worked on didn't appear to be visible to him in the 2008 footage. And we went back, we specifically looked for his gun, we found it, and I regret to say that he died only 2 weeks after we got back, and in fact we never got time to catch up with him. And when that happened, we very quickly got in contact with our other veteran, as it were. So this is Tom Fisher here. So this is a group of West Australians on the deck of Sydney sometime in 1940 or 41. They're getting ready to go on the bus or on the train home for a bit. And this is Tom about 3 weeks ago in the hive, and we were showing him this material in the background. And I'm glad his wife Shirley wasn't there, because he said to me, "This is the greatest day of my life." And of course, it was not a bad day for us to realize that we had brought some sense of resolution. So these were very young men, and all of them who survived, as that entire generation of men did, they came home having done and seen and having had done to them terrible things, and they got on with the whole of their lives. And yet, every time you talk to one of them, it's very clear that this was a crystallizing moment in their life. Not only to have done military service in that great tragic event, but also to have survived it and lived their whole lives. So that's the end of my little part of this talk. I'm going to hand over now. Thanks very much, Brett.
Thank you. And just introducing Andrew Woods, Technical Manager of Curtin Hive.
Thank you, Brett. So I'm going to run through the range of important technology equipment that we needed to pull off this big project, and also show you some of the incredible footage that we collected. So as Andrew mentioned, one of the very early contributors to the project was DOF Subsea. We obviously needed a very good ride to go back, and we well and truly got that. Over on the right-hand side here is DOF Subsea's vessel called the Scandi Protector. It's an incredibly capable vessel. Heli deck on the top there, 100 berths, huge back deck, massive crane, and importantly for us, 2 very capable work-class underwater vehicles. To that, we wanted extremely good lighting and a very good range of camera systems to collect the images we wanted. And I'll go to that on the next slide. We also fitted a multi-beam sonar, which is what produced this particular scan here. And not only that, we fitted a range of science sampling equipment, which my colleague Paul Nichols will go on in a little bit as well. So this is one of the underwater vehicles. You can see a human-sized object there to provide scale. To the vehicle, we fitted 10 of the latest underwater LED lights. LEDs very capable of producing very good light output from the 3 kilowatts of light we had available. To that, we also fitted 7 digital still cameras. Each of those was shooting images 1 every 5 seconds. And some of the cameras would also send signals up to the surface, so we could preview them in real time. We also had 2 high-definition 3D video cameras fitted to both vehicles to collect cinematography and documentary footage. There weren't enough plugs on the ROV, so we had to develop some interface housings for both the camera systems and also the lights, and a scary amount of underwater cabling. The special frame on the front of the vehicles could be oriented vertically for when we were shooting the hull, for example, or leant forward when we were photographing the superstructure or items in the debris field. When we started this project, I guess some people have probably heard of the KISS principle, keep it simple, stupid. We forgot that. And of course, we did this across 2 underwater vehicles, both for redundancy and also increased capability. This is the control room that we set up on the vessel. When we arrived on the ship, this was an empty room, and within 12 hours, we had all this equipment set up. This is for controlling our lights and cameras. On the opposite side of that wall there is this control room, which is what controls the ROVs. This is one of the control stations for the first ROV. That's controlled by 3 operators per shift, and on the opposite side of the room there's another one of those. Normally these vessels and vehicles are used for servicing oil and gas projects, inspecting pipelines, maintaining gas production platforms. The crew on board this ship were incredibly pleased to be working on a very different project such as this, and such a high-profile one. On the left-hand side is their navigation and control suite. So you can just imagine, just get an impression of the technology that's available on this vessel. The crew we had on board were absolutely amazing. We had 63 people on board, 20 people from Curtin and the museum just running the lighting and control system. Another 20 people were running the ROVs, and roughly 23 people running the vessel from the captain through to the kitchen. So April, May, we had 4 days on site. We were running the vehicles for 24 hours per day, rotating 24-hour shifts. I still have no idea what's happened some of the off-shift times. And 2 underwater vehicles to keep busy. We surveyed both wreck hulls and the debris fields, and we had to carefully coordinate the movement of those 2 vehicles over those 4 days. Sometimes the vehicles were working together, sometimes working separately, but all with the ultimate aim of collecting around 700,000 images across the full sites, around 300 hours of high-definition video, much of that in 3D, and a total amount of data, approximately 50 terabytes, which in rough speak, that's a lot. These are some of the images that we've collected. This is the B turret on the Sydney. You can see that the Germans got a very accurate bullseye hit right in the middle, which disabled that turret very quickly. It blew off the top. This is the stern of the Sydney. You can see that the stern has suffered considerable squeezing action because of the incredible depth. We're down at 2.5 kilometres at the moment. And the ROV, the second ROV in this instance, is providing support lighting for the photography on this particular shot here. The story is that the Sydney was hit by a torpedo from the Kormoran, and the bow eventually broke off. And this is looking into the guts of the broken off bow. We're looking over the shoulder of one of the vehicles, and you can see some of the anchor chains, for example. But there's just an incredible destruction throughout the entire site. This is an item from the debris field, one of the Kali floats. These were intended as lifeboats. There's a buoyancy ring around the outside. The floor was made of wood slats, and that was connected to the buoyancy ring by a rope. I wouldn't have wanted to be in one of these lifeboats because the bottom half would have been wet. Although you'd be protected from the sharks, you'd be soon suffering from hypothermia. This is on the Kormoran site. There are a lot of anemones growing on the vessel. To give you a sense of scale, some of the anemones seem quite large, very large, probably 30 to 40 centimetres in diameter. You can still see the original paintwork on vast sections of both vessels. You can see here some of the rusticles that are growing on the wreck as well. The Kormoran was carrying 200 to 300 sea mines. When the vessel was scuttled, it went up in a big way, and the mess of debris on the sea floor is an indication of how violent the explosion was. But there are still some unexploded mines amongst the wreckage. We saw 3 of them. Needless to say, we kept clear of them. And this is probably my most favourite image of the whole collection. This is one of the 6-inch guns on the Kormoran. It shows some of the human side of the German crew. They've named the gun Linda, much as some of the Allies named some of their aircraft. There are some German words here which roughly translated means victory to us and death to the enemy, and little skull and crossbones there as well. But it's also memorable in terms of the image quality that we're able to achieve as well. The water quality down there was just absolutely amazing. You can just see it almost as if it's in air, and the image clarity is very good as well. We've got very good definition. We can even see the rifling end of the barrel at the end of the barrel, which is what gives the projectile a last twist to improve its accuracy as it's heading towards its target. I want to show you some video sequences. This is the two ROVs working on the Sydney site. We're filming from one ROV, and the other ROV is providing supplementary lighting. Here we're seeing the A turret, which has been blown apart. This is where Tom Fisher was working. So he, feels himself very lucky he wasn't on the vessel when this particular action occurred. This is B turret. You can see that bullseye hit. There was another hit just down here as well. You can see the original paint work. You can see where the paint was peeled off, where the impact damage was. And you can see the other ROV working in the background there. And this is Y turret. The Sydney had 4 turrets, A and B, down the bow end, and X and Y down the stern end. And we can see that there's some wreckage that is sitting on top that particular turret. That might have been part of the battle, or it might have just been wreckage that was torn off the vessel as it was sinking into the seafloor, which is actually quite a violent act. It's not something that just occurs neatly. Again, we're on the Sydney. This is the turntable upon which the catapult for the aircraft sits. That's just been ripped off and is now sitting in the debris field as well. And once again, we can see the other ROV working in the background. This is one of the underwater vehicles we were using. These are very capable vessels, capable of going down to 3,000 metres. As I mentioned, we had 2 of these, and on the front you can see the frame and the lighting system. And, sorry, I think I just went to, oh no, this was right. This is on the Kormoran now. Again, we can get a nice close-up view of some of the sea anemones there. We can see sheets of the rusticles, which is the biological rusting process. Down at this water depth, there's very little oxygen, so the wrecks are in amazingly good condition. These anemones, most of the time, are very solid and stationary, but you can see one here that's just sort of curling inwards. It probably thinks it's caught something, caught lunch. And here is another close-up of some of the rusticles there. Here's one of the hidden guns on the Kormoran. Apparently, they were so well rehearsed that within 4 seconds they could raise the covers on the guns and set off their first volley. Again, you can see a number of anemones growing over this area. The Kormoran seems to have a lot more anemone growth on it than the Sydney does, but we're still looking at why that might occur. This is in our control room. We were beaming live 3D images up to the control rooms, and we were monitoring all of the thousands of photographs as they were coming up to the surface. And he's looking over the shoulder of Nick and Stuart there at the operations taking place. And here is one of the underwater vehicles coming to the surface. So they're quite large vehicles, and the crew are just very well rehearsed and very skilled at maintaining these vessels. So in terms of what we've been able to achieve, we've collected an absolutely amazing resource that we'll literally keep giving to us for many years to come. The digital still photographs, they will contribute to the digital 3D reconstructions that we'll be generating. They'll also feed into books, newspaper articles, and other publications. The video will be feeding into a documentary feature, which is currently being produced by Prospero Productions. Both the photography and the video will feed into the museum exhibitions, which are being produced by the West Australian Museum, and they'll be shown here in WA and also at partner institutions. There's also a wealth of research outputs which will be generated as well, not only in terms of the leading edge work we've been doing with the underwater imaging, but also with the rusticles and other science samples. Thank you.
Thanks, Andrew. Our next speaker is Paul Nichols from the Office of Research and Development, Director of Strategic Projects.
Thank you, Brett. I'm the guy in the suit. I'm not a researcher. I'm actually a failed neuroscientist. So every boat needs a failed neuroscientist on it. But luckily, I was actually part of the partnership development with the WA Museum as part of this project. What we haven't heard is that the opportunity from DOF came with very short notice. Although we'd had a number of years to prepare, when the call came, it came very quickly. So it was all hands on deck, to use a metaphor, and in addition to the researchers, we had some shortages and they needed some extra hands, so I very quickly put my hand up, and I have to say, the sense of adventure was something that really appealed to me. And I think it's something that resonated with me around the tour, that the things that the crew of the HMAS Sydney and HSK Kormoran would have also felt as they went out into the ocean, into battle, but nothing that I can compare to. So the opportunity for us to go and do this work actually provided a number of problems, and they were particularly around the constraints of what you could and couldn't do in a heritage site. And so we did a lot of work with the museum and the Friends of the Museum, and obviously the Finding Sydney Foundation, to actually understand what some of those sensitivities were. It's a national heritage site, so we had to get permissions to actually touch and collect samples in the project. Similarly, there were significant technical constraints, and I think Andrew hasn't quite told the full story about how technical it was, but they're in the order of 200 connections from a camera 2.5 kilometres down in the ocean back up into the control room. And anything could go wrong, and he hasn't told you that we went and did a test at about 400 metres on the way out, and quite a few things did go wrong. And I guess what was really amazing to me was the quality of the DOF Subsea crew, the WA Museum staff and the Curtin staff, all working together to solve these problems in a very short time frame, in a very constrained and stressed environment, and they actually pulled it off. So I think that's something quite amazing. The other challenges are at 2.5 kilometres in depth. There's a lot of things we don't know. We don't know how pressure will affect the sampling, how difficult it will be to get a ROV to operate and actually pull up a sample, and also some of the things that we don't know about the actual chemical environment at that depth. So what the project did do is provided us an opportunity to go and do a broader scientific program beyond the core program, and it was quite unique. The sorts of things that will tell us is about how metal reacts underwater, how it has an impact on the environment, how that might compare to a ship of the same age or an oil and gas platform of the same age. And Dr. Laura Machuca-Suarez is going to tell us a little bit more about that in detail. So I'm just going to cover off some of the things we did. So you can see the broad range of researchers that this research project has provided opportunities for. They range from geochemistry, corrosion science, environmental sciences, spatial scientists, and of course DNA analysis, because some of the things we found at that depth were quite significant. We had a range of technical equipment, and Andrew's talked about some of this in detail. We've got the ROVs. What we did have was this robotic arm, which proved absolutely invaluable. It enabled us to manipulate different pieces of equipment through the operation of the ROV guys to actually enable us to capture these samples. Obviously, we had cameras and we had networks, and that was where a lot of the complexity of this project came in. But we also had very technical equipment. So we had a pilot gaffer. All right. We had cable ties, we had hose clamps, and we had milk crates. Not as attractive of milk crates as those, by the way. Now, one of the things about cable ties is you can never have enough of them, and so we brought tub loads of cable ties with us. We ran out of those. The boat's crew ran out of their cable ties, but somewhere miraculously these cable ties just kept emerging, but just as well because there was a lot of them. So I'm just going to quickly go through some of the scientific collection equipment. So the Rustal collector here, have we got a laser pointer on this? Oh, top button. Aha, yes. So this here is aluminium steel. It's actually, stainless steel. It's actually created so that the manipulator arm can use it. And this is how we're collecting our corrosion samples. And I'm going to show you a sample of that in a minute. You can see Niskin bottles. So these enable us to go down to depth and actually then trigger the Niskin bottles using the other ROV. And what happens is this cap here will close and it capture the water at the depth we're at. We then bring that up, put it into an environment where there's no light and able to get to it. We give it samples and then we bring it back to the university to do tests on it. We have here sediment push corers. So this enables us to get a sample away from the ship and at different distances, so we can see what's happened in the subsea environment moving away from the ship. You can see here gaffer tape again in use, lots of hose clamps there. And down here is another piece of equipment called the crab trap, very scientific name. And this we would place on the sea floor away from the ship and leave it a couple of hours, then come back and see what we could collect. Now you will see here a piece of rope and a little bulb here on the top here. What we have there is actually called a monkey fist knot. And some of us used some of our spare time to actually learn how to do monkey fists. So I challenge you all to go on the internet, find out how to do a monkey fist and see if you can do that. What it enables it to do is the rope actually sits above the bottle so we can go and collect it later on. So what it all looks like is when it's decked out, we have go back on that. So what we have here is the Niskin bottles attached to the ROV. So we had about 10 of these located at different places on the outside, of course, so that the other ROV could come across and connect it. Here's our manipulator arm. What you can't see in here is the milk crate where we put a lot of the equipment. This piece of equipment here is a cathodic protection probe that enables us to determine how much corrosion was happening. So the ROV operators could actually get this ROV right up against the ship and hold it on there so it could actually get the current and run it through that. So the actual ability to control these ROVs was quite amazing. So now we're just going to show a little bit of video of collecting of samples. So here is the cathodic protection piece of equipment. And you see this is the ROV sitting against a piece of the hull that was away from the main wreck. And that was transmitting data straight up to the, back to the ship. Here is a Niskin bottle and 2 ROVs at this depth, probably 4 metre swell up at the surface. And you'll see after a couple of minutes, we won't be watching that long, but you'll see it triggers the white piston here. Got it. So there we've got a sample of water from 2.5 kilometres down. This is rustical sampling, very intricate operation. We're trying to take as much care as we can when we're getting these samples. Just remembering 2.5 kilometres down. Clunk. And these samples were then brought back. The WA Museum and Curtin researchers are now doing this, and Dr. Laura is going to tell us all about what she's actually doing with these samples. Again, push cores. So this is pushing a sample into the earth. So first of all, that core had to be pulled out of its bucket, placed in there. This is sped up at 4 times the speed because it's a very intricate operation. Coming out of this one here, you'll see a mud sample, and sitting on top of that, there's actually a sample of corroded steel. One of the rusticles that's fallen off the ship. The first couple of these we did failed, and the guys on the DOF Subsea ship were able to actually help us reconfigure the equipment to enable us to achieve this. Okay. So in summary, the samples, the rusticles, you've seen some of the anemones and of course the mud sampling. These are some of the marine life that we've seen. We've only gone through a certain number of hours of the footage, but you can see already there's some significant sea samples. So on that, I will hand over to Dr. Laura.
Thanks, Paul. And just introducing Dr. Laura Mashuka Suarez, a lecturer in the Department of Chemical Engineering.
Hello. Okay, so my name is Laura Machuca. I'm a researcher at the Curtin Corrosion Engineering Industry Center. Together with a beautiful multidisciplinary team of scientists from Curtin University and the WA Museum, we were given this beautiful opportunity to look at the rostacles that are actually growing from the, on the surface of the wrecks of the Cormoran in Sydney. So these rostacles, or rust color icicle-like structures, are growing on the surface of the two wrecks. They have been observed also on other shipwrecks, such as the HMAS Titanic at 3.8 kilometers deep water. And they are known to be very complex structures of different minerals, iron oxides, ions from seawater, and they are known to be home for a very complex community of microorganisms. So basically what we want to do is understand the formation, identify the rustical properties, and understand what's the role of these microorganisms within the whole structures. That will allow us to predict what's the deterioration rate of these two ships. Based on these studies, we also want to extend our work to actually model deep water corrosion, which we can use to apply also to historical artifacts and to assess the integrity of other subsea structures such as oil and gas production facilities. So this is actually one of the samples that we have in the laboratory right now. These are some scanning electron microscopy images of these rustacles, where you can appreciate how beautiful the minerals and the iron oxides there are. So just to give you an idea, this is a 2 micrometer scale. So there's really microstructures. So what we want to do is look at what's the composition of these structures, what's what we actually have in there, whether the structures are different in the Cormoran and the Sydney, and how are those compared to previous work that have been done on other shipwrecks. These beautiful structures as well here, these are actually remains from phytoplankton that drift to the bottom of the ocean, and they died on the surface. So, and this is actually beautiful evidence of the microbiological work on the rustacles, where you can see also this is a 10 micrometer scale bar, and these tube-like structures correspond to mineralized bacteria. They are known to be playing a very critical role on the degradation of the wrecks, based on all the research that have been conducted on the other shipwrecks. And the microorganisms from the rustacles have been successfully cultured in the laboratory. They are growing at 3 degrees. We provided, trying to simulate as much as possible the conditions that they have actually in the deep waters. And these are how they're growing, and these are the microbial cells that are growing in there. So basically, this is, as I said, a multidisciplinary research where we have corrosion scientists, environmental microbiologists, physicists, and molecular geneticists working on this to actually put everything together, looking at the microbes and what's the interaction of these microbes with minerals, and how the whole process is affecting the degradation of the wrecks. So that was a brief thing, unfortunately, but we're working on that currently, and we'll definitely be releasing results of our studies soon. Yep.
Thank you, Laura. Our next speaker is Joshua Hollick, visualization technology specialist from Curtin Hive.
Good evening, everyone. So tonight I'm going to be speaking a bit about the 3D reconstruction aspects and image processing aspects of this project. So these have been touched on briefly by both Drs. Andrew Hutchison and Woods earlier. So this is some of the technology that's enabling us to create ideally a complete 3D model of both the HMAS Sydney and the HSK Kormoran, and also of significant items in the debris field. So using these, we can then use these as pieces in a museum exhibition in various ways, either in virtual environments or perhaps even using some of the upcoming techniques of 3D printing to create actual artifacts that we can look at. So when we're talking about 3D reconstruction, it's essentially the way that we're doing it is known as photogrammetry, so creating 3D models from photographs primarily. But the reason I'm not using the term photogrammetry here is because while photogrammetry is the base technique, photogrammetry is sort of only from photographs in many cases, but in some cases we may need to touch up the models with a sort of a human hand to fill in any gaps that we see. So primarily we're going to base this on the still images. So as was mentioned, we've got roughly 300,000 images over the 4 days. But we've also got lots of video data that we can also use. Now, since we're at university, it's, I suppose, time for a quick tutorial of how photogrammetry works. So the way this works is slightly complicated, but essentially it works by the computer gets each image and analyzes it to find feature points. So these are interesting points, and I've marked several of them here as found by one of the computer programs. So each of these points the computer thinks is something that it can then find in other images as well. So using these, we do this to every image that we have, and then it finds matches between images. So in these cases, all of these lines here are matching points between images that the computer thinks are a good match. So these would be, say, the corner of something or a distinctive spot, things like that. So all of these lines are matches, and the blue ones are ones that the computer has determined to be correct for geometric reasons and various other things. And the red ones have been rejected for reasons like that. Then we can do a process sort of known as a bundle adjustment, where we adjust and work out the correct positions of all of the cameras and all of these 3D dots. So we end up with a very sparse point cloud. It's not necessarily detailed enough for us to do anything with. But now that we know the locations of all of the images, we can very quickly, incrementally build that point cloud up using much more detailed analytics to create a much denser point cloud. And now you can start to see the actual geometry of what we're looking at. This then can be turned into a mesh where we encode the geometry but not the colors. And then finally, using those photographs, we can project them onto the mesh. So now that we've got a photorealistic, complete 3D model using photogrammetry. So some of the experiments that we've done, as mentioned, we've been slowly scaling this up over the last few years. So because we're comparing in the naive, easy way of doing this, we compare every image to every other image. 40 images takes an hour, and it very quickly becomes a problem. So this 40,000 image set was one that we ran on the 2008 data set. We reconstructed pretty much the entire hull or main section of the Sydney from the video. It took about 6 months. We spread it across 3 computers so it was quicker. But if we extrapolate this out, we end up with a problem. No one's going to wait 2,000 years to see our museum exhibition. Thankfully, across the road we have the Pawsey Centre, and they have the Magnus supercomputer, which is currently the fastest computer in the Southern Hemisphere. And this image matching process is near trivial to parallelize across the entire computer. So this computer has a bit over 1,000 nodes. So if we get to use all of them and just put this on the supercomputer, it'll take somewhere between 1 and 2 years. That's still a problem because no one's going to give us the supercomputer for that period of time. So there's a lot of other optimizations that we can use. So underwater, your visibility, as you've seen in some of the photographs, is limited to maybe 3 or 4 meters, sometimes 10 if you've got the other ROV providing lights as well. So on the ROVs, we've got the ability to track them, so we can then use that to make things quicker. So some of the work we've already done on this, we had an intern, Lou, who worked on this at the beginning of this year and confirmed that, as our suspicions are, that we can parallelize this quite easily. Also, underwater, there's various other issues with photography. So over here on the left are some of the original images or sections of images from the 2008 data set. So in both of them, you can see, well, at least in the top left one, it's quite obvious here that it's very, very blue. It turns out the water absorbs red light very quickly. And we want to make this as realistic as possible and as accurate as possible, so we need to correct for that. So with another intern and some work, we've done work on restoring that colour. So using the depth that we get from the 3D reconstruction, we then know how far it is, and we can then correct for the light fall off. So then this is an example of what it could look like. As you can see, there's much more red in it. It's probably much more accurate. We've also got white balance issues between all of the many cameras that were explained earlier, so we need to correct for that. And also de-blurring. So underwater, you've got issues of light, obviously, and movement and various other things. And there's a whole area of de-blurring images where algorithmically we can work out what that blurring is and then reverse it. So using this, we can do a much better job of actually seeing what it is and fix the issues that we had along the way. So once again, we had another intern working on this island, and we've got some good results out of that so far. So these are more things that we can run on the supercomputer and will make things take longer. But hopefully with some optimizations, we can do this in a reasonable period of time. So also, as you've seen, we've also collected not only images, but location data of the ROV, as well as some multi-beam sonar, which essentially gives us a crude 3D model of the ship, and various other things. So in 2008, they didn't do a multi-beam, or not a detailed multi-beam survey, but we did. So my PhD work also, as we're going through this, is sensor fusion, where we can combine all of these different elements together to create a much more complete model. So I've been told that every good presentation where you're teaching has to have an equation. So we have one. So this is the multi-beam data. So as you can see, it's got this sort of crinkle cut thing like you might see on some chips. Obviously, the Sydney has not crunched like that. It is roughly flat along here, as you've seen from some of the images and video. So combining things like the multi-beam data with our giant image collection and some of the 3D reconstruction, ideally, we're going to create a giant complete model of both ships with much less errors than what we've got using either one of the techniques by themselves. So now we've got a quick live demo, and hopefully this works. So using the 3D reconstruction, this gives us a lot of ways where we can have a look at things that have happened across time, both comparisons between the 2008 images of the Sydney, as well as the original ship's plans. We can compare the 3D models from the ship as designed with images from the 2008 survey, as well as our survey earlier this year. So what you're looking at here are two of the ship's boats from the Sydney. We've got the Whaler and the Pinnace, and I'm sorry the image is a bit dark, but what's here is you can see this ship here, or this ship's boat, is relatively intact in that its shape is correct. It hasn't decayed to the point yet where it's falling apart. Now I'm showing you this because this is probably our best example of degradation of the site just in the last 7 years, between 2008 and 2015. So if we have a look at some of the 3D models that we've generated today, what you're looking at here is these same two ships, and now this one here has started to decay and fall apart even more. So part of the rationale and the reasoning behind this trip is to provide a snapshot in time of these wrecks as they are now, before they start to degrade even further. So all of these models that some of these models that we're going to go through here, these are all preliminary works, so I apologize in advance for any holes or issues that you may see. So these have been done as a sort of a precursor to our final renders. So these are, each of these is hundreds or even thousands of images in some cases, but most of these have been rendered on a relatively low quality so that we can get them out quite quickly. So this here is another one of the ship's boats from the Sydney. So each of these is about, say, 2 meters wide and maybe 10 meters long. So it's something that the scale can kind of get a bit missed without other things. So over here on the front, we've got the badge from the Sydney. So this identifies it as being part of the Sydney. It's one of the iconic parts of these boats. So there's a lot of different things here. Here we go. So now we're going to pan across to the bow section of the Sydney. So as was described earlier, the Sydney was hit by a torpedo and the hull snapped, so it's broken off with the bow sunk separately to the remainder of the ship. So this here is the bow section sitting upside down on the seafloor here. So all of this detail here is in the 3D model, and we can compare things like the growth of these rusticles between 2008 and today. And there's quite a lot of growth looking at these. So in some cases, these rusticles were, say, only up at here in 2008, looking at the images, and now we can see just how far they've come. We can also measure, once we scale this correctly, we can also measure the volume of these things, so we can see just how much things have moved physically, distances, the scale and the volume of these rusticles. So it's still an open question, I believe, as to how quickly some of these rusticles grow at these depths. So it's very rare to see data collected both from this depth and also a snapshot in 2 different periods of time, which is something that we've achieved here. So, what else? So I think these are some of the smaller models that we've generated so far. We've also done some of the Kormoran, so I suppose please don't feel like we're favouring the Sydney in some ways. It's just that these are some of the nicest, prettiest models, I suppose. So here we've got the other one of the ship's boats. So some of these are made of wood, and you can see it's starting to degrade over time. Some of these holes, such as this here, these aren't actually in these photographs. This is a current artifact of this particular reconstruction. So these reconstructions are getting better and better over time. So there you go. So sort of in conclusion, I think I'd like to stress that this is a very multidisciplinary project, so even with the 3D reconstruction aspects of it. So while technically I'm employed in humanities, this is also a collaboration with spatial sciences and Centre for Marine Science and things like that, and other places, such as design and art. Also, this is essentially bleeding edge technology. It's sort of only recently that computers have got powerful enough that we can run reconstructions of this size in reasonable periods of time. So on those notes, I think I'd like to hand over now.
Absolutely. Thank you. Thanks, Joshua. Could all the speakers come to the front? So we're going to have a question and answer session now, and we are recording this session, so we'd ask that you wait for a microphone if you've got a question, either for a specific speaker or just to the panel generally. So, questions?
Yes, sir.
If you can just wait.
Yeah, microphone coming down now.
Thank you, fellas. My name is Harvey from Kalamunda. I'm really interested to know, did you find the Sydney first, and then how did you find the Kormoran from it? Did you have enough information to lead her in the north, south, east to west direction?
Well,
Thank you.
I might speak to that. So this needs to be said, we didn't find the wrecks. That was done by the Finding Sydney Foundation in 2008. And so that was a 20-odd year process for those researchers who did that. So they did the extraordinarily difficult thing of finding the 2 wrecks. And in 2008, they first found the Kormoran and then followed in the directions that had been given them basically by the German account and found the Sydney right where the Germans said it would be in relative terms, which is to completely trivialise how big a problem it was for them to solve it. I'm making it sound easy. So we had the enormous luxury, and what we did was only possible because we already had the GPS coordinates. So when we went back, the DOF surveys put us within 150 metres or 200 metres of first the Sydney. So we visited the Sydney first, and then we moved on to the Kormoran. And the other thing that made it possible for us to do so much here is because the 2008 material, while I said that it wasn't good enough for presentation to the public, it absolutely gave us a complete roadmap for where we should go and what we could do. So we did the Sydney first, and then fortunately, because of the sponsorship we got from GMA, we also had enough time to go and do comprehensive work with the Kormoran. And it's possible that we've discovered more about the Kormoran new than we did about the Sydney, because so little was known about the Kormoran from the 2008 material. Harvey, is that answering your question?
Yeah, thank you.
Okay,
I
thank
think
you.
there's another one over here.
Ex-Navy. I just wanted to find out about the Carly float that was supposed to be on Christmas Island, if anyone could tell me about that one.
We haven't got anyone here who's a particular expert on that. And I'm going to tell you everything I know, but I feel bad about that because there are actual experts in the audience here. I see Wes Olsen sitting there, who's written a book about the Sydney and the Kormoran, and another one. But so basically, the Carly float that was found on Christmas Island in early 1942 was initially, so there was a skeleton in a uniform in fatigues in that Carly float. Initially, it was not believed that it was a survivor from the Sydney, but after, once again, a very long story, including exhuming the body from an unmarked grave that had moved down the side of a hill because of the climate and the soil conditions there. It is now believed that it is a sailor from the Sydney, and I believe that they're close to identifying who it is. But I only say that because they did some dental work. So unfortunately, the dental records for the sailors went down with the ship because they were all held on the ship. So when you moved from one ship to another, you took your records with you. So it's possible that that sailor, who is now buried in the cemetery, the military cemetery in Geraldton, is going to actually be identified as an individual. But I don't know exactly where that's up to. And so I wouldn't want to comment any more on that. Is that answering your question?
Yeah, thank you.
More questions? Yes, please.
Hi, I'd just like to come back to the image recording, and I know that you guys struggled to get 4 days of recording on the site, and 700,000 images is a lot, but did you capture everything? Or I guess were there places that you couldn't get the ROVs into or were too dangerous as well for the 3D recording?
Andrew Woods.
Thanks, Maddie, for your question. It's a very complicated site, and it was a job and a half trying to direct 2 ROVs on opposite sides of the room and make sure we'd covered everything. I'm sure we did miss something, but we certainly covered all of the important areas of both ships. You know, time will tell as we go through our processing whether there are any gaps. We did lots of passes, so you know, there might be some areas that we only covered from a fair distance, but yeah, we did as good a job as we can in the time available.
I can answer that.
We would have loved more time, but we think we did a pretty good job in the 4 days. Probably what we didn't cover in complete detail, or as much detail as we would have liked to, is probably the debris field. We really were only able to cover that area in a very incomplete fashion. There were some areas which we knew specifically, some items that we had to go to. We were examining some areas that had not been looked at before, particularly relating to the Kormoran debris field. And you know, everywhere we looked, there was more interesting stuff, but time was expiring, and we had to pull up eventually.
So can I just add to that, Andrew? There were a number of issues around how long we could stay out there. There was a cost issue. There was our desire to try and balance the Sydney and the Kormoran imaging. And luckily, we were also able to try and integrate the science program. So a lot of this was done on the fly. And as things happened on the boat, we had to react very quickly to try and optimise the opportunity. I think we did pretty well. And I know that the WA Museum staff, and Nick's here somewhere, even helped us through construction of models on the ship, which which enabled us to get a good sense of where we'd been and where we hadn't. So it was a really, really good collaboration in that sense.
I mean, I'll just add that what we did have in common with the 2008 was that, well, we only had one cyclone. In 2008, they had a couple. So we actually ended up cutting short our planned time on Sydney to make sure that we would get enough time on Kormoran. But the other interesting thing is that in the 2008 mission, they covered parts of the debris field we didn't get back to, and we covered new areas that they didn't see. And one of the things that we will be doing is to join those two data sets into a superset that will marry all of the knowledge we have together into one site map.
Yes, please. Just down here.
Thank you. Tamara from Landgate. That was a fascinating presentation, and at the beginning you were showing a vision of making this information to the public and the design. What's the timeline for that? When will it be available to the public, and what sort of, is the vision still there? Is it still the same?
Well, so James Dexter from the WA Museum is actually going to talk to that exact issue. So I think I'm going to leave that to James, if that's okay.
Another question just here.
I wonder if you're going to be doing the same thing with the Titanic. I mean, it's a much better story here, and it would be great. It would be great for the whole world to see that we've got a much more exciting story here than the Titanic. I feel sure that the structure would be much more intact with our shipwrecks, and a much better story as well.
So, well, with regards to the Titanic, that's the only other shipwreck that's been in these depths that's a large metal shipwreck that's ever been studied. And so there's a huge legacy of work there that's been done by Woods Hole since they found the Titanic in 1988, I'm pretty sure. And they've been back there 5, 6, 7 times. And we were consulting, Andrew Woods and I, with Bill Lang, who's their Andrew Woods, in that he was employed to design the camera systems for the initial search and discovery, and he's also been involved in almost every design. And every time they've gone back, it's been with newer and better equipment. So the interesting thing is that they were doing one ship, and we were doing 2. And so Bill Lang was very clear when he said, one day is not enough. And then I ring him back and say, oh, we've got 2 days. He said, it's still not enough, and so forth and so on. And probably because the huge advantage we had was that, A, we knew from the 2008 survey where we were going, what we were doing. But the other huge advantage we had is that normally expeditions like this are using scientific research vessels, which are nowhere near the level of capability that a very modern oil and gas support vessel is. And we had the astonishing luxury of the best equipment and a huge crew who could just solve all these problems. I mean, we had 2 ROVs that could operate simultaneously and work together. It was just an impossible alignment of the planets for us.
So, Laura, the rustical research around the Titanic, I think that's pretty important research that's going to help inform the work that we do on the Sydney and Kormoran.
Yeah, all the research that was done on the Titanic really helped us a lot to know what to do with the rusticles, how to handle that, and get a bit of understanding that what was happening there. And it was very exciting to see very similar structures that have been described for other shipwrecks. And definitely it seems to follow actually the same pattern of degradation despite being so far away. So it's basically a degradation of the steel, and also we have these new techniques and high resolution methods that were not available before, and that hasn't been applied to any other processes or degradation processes previously. So it's a privilege, and it will definitely help answering a lot of questions that are still there about the mechanisms and of degradation of these artifacts and shipwrecks in deep water. So it's a very important thing for us for Curtin University. Yeah.
I was wondering about the marine growth. Are these wrecks sort of oases for marine growth, or is it everywhere else and you didn't bother photographing it there? But the anemones particularly like the steel and the iron.
Yeah.
So
yeah,
I can say from the non-marine science guy, and I'm representing the marine science guys who aren't here, but they're up in the Galapagos as researchers are. What actually really surprised me was that the landscape was quite barren. There was nothing to see until all of a sudden you'd hit these shipwrecks. And the Sydney was really about corrosion, but the Cormorant for me was actually around the biological materials, the flora that was actually being grown there. And I guess the challenge is understanding what was the difference between the two metals. Maybe the fire had an impact on the paint, and how the paint was actually providing the burnt paint was providing something to nourish on. And as I said, this is purely non-scientific speculation, so I thought that was quite fascinating for me.
Rossicles are definitely growing on the areas where the protective paintings have been damaged. So it's definitely where the steel has been exposed to the environment. So, yeah.
So the shipwrecks absolutely do become an oasis for at least the reason that they're a fixed structure that things can grab onto. So most of that stuff, it's called the abyssal plain. It's just flat, oozy mud. So the wrecks are absolutely like an artificial reef. Yeah.
For the Titanic, at least 25 species were characterized, bacterial species. We're currently working on characterizing what we have compared to what has been described, but definitely there are mainly iron metabolizing bacteria that are living on all these iron that have been, released from the degradation of the wrecks.
I think we've got another question.
Thank you to all the speakers. My question's addressed to Josh and or Andrew Woods. Josh, you showed us footage of 3D reconstructions, but I was wondering if you had the capability or the plans to actually use the 3D technology to be able to project the footage in 3D form and create an immersive experience that can be, say, shown in the hive.
Yeah, in short, yes. So while I showed you, at least on this screen, it's 2D, we did capture a whole lot of 3D video. We've also got now these 3D reconstructions of what we hope to be the entire wreck sites and parts of the debris field. So as Andrew showed in one of his slides, there was a potential to create an exhibition where perhaps we might be able to use these 3D models to create maybe a virtual submarine or something of those likes, where we can see parts of the wreck from any viewpoint that you desire. So then you can have a look at it from places that we didn't, from positions that we didn't look at.
Okay. I think we've got time for one more question.
Yeah, hi. I'm another Andrew. The question really is that this is a complex and perhaps hypoxic or anoxic environment. Is it possible at all that the intense lighting systems and even perhaps water flow from the thrusters in any way impacts the rate of growth of rusticles and other features on the wrecks themselves?
Might be one for you, Laura.
Sorry, I think the question is it possible that the light from the ROVs and even the
thrusters, even though it's there for a short period of time, is it likely perhaps, or will we ever know if it has any impact on the rate of growth or the energy within the biological medium?
Well, we believe the microorganisms or general organisms that are like kind of photosynthetic and then can add, extra activity around. If they are dead, they're dead. They are not there. They definitely need the surface light to live. So we believe there are no such as microorganisms that can be available to live on this extra light provided and alter the degradation process. So there could be some chemical associated processes, but they should be very slow and insignificant to take into consideration, yeah.
We're going to have to wrap up the question and answer session there, but I know there's other people in the audience who want to ask questions and very curious about the presentation. So I'd encourage you to either speak to the presenters afterwards or to get in contact with us following the presentation, and we'd be more than happy to answer all questions. I'm sure each of the speakers could have talked for about an hour and a half themselves, but thank you very much for the Q&A. So I'd now like to invite James Dexter, Director of Creative and Regional Development, WA Museum, to talk about the partnership.
Thanks very much, Brett, and thanks very much to the speakers before me. As the delegated, museum is the delegated authority for the protection, for the interpretation and preservation of shipwrecks in WA, the museum, once the Sydney and Kormoran had been found in 2008, did develop a small exhibition in Geraldton, Pride of the Fleet, which complemented the very moving memorial in Geraldton, and in fact has sort of made Geraldton in many ways the pilgrimage centre for the commemoration of the Sydney and Kormoran. However, as Andrew Hutchinson has pointed out, we were faced with a problem, both time, this was put together in 8 weeks, space, a very small space, obviously no objects, but I think the other thing was those images that came out of the 2008, they are powerful, but they are ghostly and grainy, and they can't really provide that type of interpretation or exhibition experience that we'd been looking for. So therefore, the museum went down two roads. One was to actually get the funds and to improve the Geraldton site so that we could actually house, I keep now never using the word immersive experience because it seems somewhat inappropriate in this situation, but an experience that we could somehow tell that story in a manner that was honest and respectful to that tragedy in Australia's history. And the second thing was when Curtin University brought forward the idea of going back to the wrecks to film them, to become strong partners in that collaboration. I think that's the other thing that comes out of this, is that in the current situation, or not just with the funding, but with the complexity of modern presentation, there's no way the museum can do things like this on its own. It's only it can work through collaborations with, in this case, universities and industry, with DOF and with the support of places like GMA, who provided some funds as well. So when you've seen the imagery that has come forward, you've seen Josh also talk about creating these 3D models. I obviously struggle when talking in these ways. I sort of know what I want, but I certainly can't articulate it. But we're looking forward. At the moment, we have a business case with the Midwest Development Commission for a very large sum of money, which would be to expand and improve the Geraldton Museum. But the hook that has always been there has been that we can properly tell the Sydney-Kormoran story. Now, we have to finalise that business case in 3 weeks' time, so we'll be very busy in doing that. We're pretty confident that that money will be there, and the major part of that will be this digital presentation of the Sydney-Kormoran experience. But it is complex because a 3D model, and we've talked about investigation or fly-throughs, I think that's good, but you've also got to be very careful that you don't descend into the video game sort of concept. There's got to be that respect there. I think there's also got to be something that Andrew Hutchinson talked about, which is the stories. We've just, as some of you might know, we've been very involved, or I've been very involved all last year in putting the National Anzac Centre together in Albany. And the strength of that, the incredible success of that, came out of telling personal stories. So I think it needs to be a combination of that 3D modelling, that experience, which makes, I think it was Andrew Viduka from the Federal Department of Environment that talked about making the accessible inaccessible. Sorry, flip it the other way. Making accessible the inaccessible. If you ever got an inaccessible site, this is it. I mean, we may go back, but I doubt it, at least, you know. And so how do we present that to the public? Now, that's our big challenge. If we get the money for Geraldton, we are hoping to have that opened in 2000, well, we said 18, but it won't be, it'll be 2019. At the same time, we're building a new museum, so we've got a lot on our plate. We would also seek to have some of that experience in the new museum. It is such a powerful, important story in Australia's history. And it's a story that has been for so long unresolved that this might be the chance to properly resolve it and to properly pay the reverence to all the people involved. But there are other things that spin off like that. One of the things that, if you go along the coast, you'll realise that Geraldton, with its memorial and everything, creates some friction with places like Shark Bay and Carnarvon, who say, why Geraldton? Shark Bay in particular says we're closer. So what we'd like to do with Shark Bay, and I'll be up there in a short time, is to look at presenting some of that 3D footage there and talking perhaps about the battle, because that's the closest to the battle. Whereas in Carnarvon, where at the mile-long jetty, they have supposedly the lifeboat from the Kormoran to talk about the Kormoran story. There are other places in which this story will be told as well. The National Maritime Museum in Sydney has been a partner in this, a junior partner, but has been very supportive and has put some money into the whole process. And they want to, in the near future, actually have a small interactive display looking at the archaeology on it in their new warships pavilion on Darling Harbour, and they would like to work with us when we talk about what might happen at Geraldton. And the War Memorial as well is interested in having, again, either a 3D or presentation, but especially linked to their exhibit, which the prime, in fact, the only real physical object which was referred to a little while ago, the Carly float, is there in Canberra, and to perhaps have something like that. So that's what we're looking at the moment. I think the huge challenge is how do we get there? What do we do, as well as the money? But how do we get there? How do we take that 3D modelling? How do we take the 3D video and create it into an experience that is satisfying and has that wow factor without in any way diminishing or trivialising the story? We have found with the National Anzac Centre that such stories are very powerful, but really interestingly, they are economically very successful. What we look to in Geraldton is something, and why the Midwest Development Commission would be putting money in, is partly to see what the economic multiplier in that community would be. And that's why we're very interested in having it centred, the major experience in Geraldton, which is the largest place closest to the actual battle. So that's what we're looking at, and sounds easy, but it will be a collaboration, obviously, with Curtin, with others, for us to put that forward, and we see ourselves as a place that can become the public showcase or the public face of this. Thank you.
Thank you. Thank you, James. And just in closing, this event is part of Research Week at Curtin University, and it's a time where we take great pride in the research conducted at Curtin. And we've had our share of good news in world rankings recently and the regard in which Curtin's research is held, but we've also got a very proud history of doing research that makes a difference, and in partnering with industry, community, government agencies to really make a difference to the community, I guess. And so I think this is a fantastic event to demonstrate those ideals, and I hope everyone's enjoyed it as much as I have. In terms of Research Week, we've got a variety of events happening if people want to engage, and we've got science and engineering based lectures tomorrow, tours of the Geoscience Atom Probe, which is a very new facility at Curtin University, and the Curtin Hive that we've heard a lot about tonight. So there's tours of that facility as well. We've got the Mark Liveris Student Research Seminar and the Curtin University Postgraduate Students Conference on Thursday, and the Curtin Research Awards for Friday. So there's a lot of big events happening this week, and hopefully we'll see you again. So on behalf of Curtin University, I'd like to thank all of the speakers for the presentations, but also to thank all of you for coming out and being part of this event. So thank you again.